Hi there. I'm going to be talking today about College Algebra XYZ textbook section 2.3, and it's on functions. And this is just defining some different kinds of functions, and then we're going to move on and start combining everything we've learned with all of the different equations with the functions that they are. So the first thing is a definition. So a function establishes a correspondence between a set A and a set B with different elements in each one. So as you can see here, there are four things in the input. So the blue is the input, that's set A, and B is the output. And as you can see, there's four inputs and they create three outputs. That means there is one here that has two different inputs coming into it, and that is okay. That's considered a function. But if we had something different happening where we had one input going to two different outputs, that would not be a function. Okay, that is not a function. So every single input can only go to one output. All right, so, and we're going to look at what that means as we move forward with this when it comes to a graph. So here's another, let's see if I can fit this all together. No. So here's another picture of what that looks like. The input is x, and the output is f of x, which we say function of x. Right here, this is function of x. Okay? So functions can be described by using a table. They can be described using a graph. They can just be a word description. They can be an equation. There's lots of different ways to talk about a function. So here's some terminology for you having to do with functions. And I was thinking about everything that I've ever heard. I'm sure there's some other things for these different situations, but the input, as you can see up here, the input x that comes into the function, that is going to be the independent variable. So that's what we put into the equation. It's called the domain. That's really important to know, and it's usually x. So, but sometimes, as you all have seen, it's t or it's a or it's something else, but it's usually x, and it is also, I forgot to say this, the x-axis. So it's going to be the x-axis. The output is the dependent variable. This is called the range, also important to know. That is y. It's also called f of x, function of x, and it is the y-axis in a graph. Okay, so make sure you have all of that in your notes, put a big star next to it. Okay, a couple of observations, and you can find these in your book actually, but a function can be assigned any name. They don't have to be called f. So you'll see things like g and h often. So you'll see g of x, you'll see h of x, and that's because often they're trying to denote different functions in the same scenario. So they've got, this isn't, now we have a way to talk about different functions together. The variable x in f of x is a placeholder. It can be replaced by any quantity as long as the same replacement occurs in the entire expression. So x, the way we're now writing this, f of x, means that now we can say f of 2, which means x equals 2. Okay, that's what that means. Or we can say f of a plus 3, and that means a plus 3 is equal to x. Okay, so this is now a way for us to be able to talk about that. So one way that we use function notation is to evaluate a function. It's very useful for this, and so what I did is I just made a picture of problems 17 through 24 in the back of section 2.3. So again, we're on section 2.3, so make sure You know where to look for these. And I think it's a good idea to practice these because they're simple, but if you don't understand how to use them and practice it a few times, you may have some misconceptions. So make sure you practice these. So I'll just do a couple of these. So let's try 18. So it says f of x is equal to negative 2x minus 1. And they want us to evaluate for f of a plus 1, and f of 1/2. So what that means is when we have f of a, that means we just replace every x that we see with an a. So I'm going to say negative 2, and I'm going to put an a in everywhere there's an x, minus 1, and that's it. Because that one was really simple, so there's nothing more that we need to do. The next one is f of a plus 1, so it's just a little bit more complicated, and there may be some distributing or something that we need to do. So we're going to use parentheses anytime it's any more complicated than just a single variable that we're replacing it. So that means anytime we see an x, we're going to replace it. So here's our x. We're going to replace it with everything in here. This whole part right here is going to go in for the x. So we've got negative 2, and instead of x, I'm going to put a plus 1. So every time I see an x, I'm going to put what was inside the parentheses, the f of a plus 1, minus 1. So now I'm just going to distribute this and say negative 2a minus 2 minus 1. So that gives us minus 2a, or negative 2a, minus 3. Okay, so the next thing we want to do is do the f of 1/2. So that's the next one that's given here. F of 1/2 means every time we see an x, we want to replace it with a 1/2. So going back to this equation up here, the original equation right there, we're going to say negative 2. And every time you see an x, you want to put a parenthesis. And for this simple one, it's not as important, but you'll start to get more complicated ones, and you'll be happy you started doing it this way. Minus 1. So notice it looks just like the original, but the x has been replaced with 1/2. And we're going to get negative 2 times 1/2 is negative 1. Still have a minus 1 there, so we get negative 2. So f of 1/2 is minus 2, or negative 2. Okay, so I'm going to leave the the odd numbers for you to try, because the answers are in the back of the book, and I really think you should try these and look at the answers in the back of the book. So these are from section 2.3, and you can just take a look in the back of your section there. All right, I think next I'm going to try 20 because it's got a square in it. So f of x equals negative 2x squared plus 1. So the first thing we're supposed to do is f of a. And we are going to just replace every x with an a, so we get negative 2a squared plus 1. Notice I didn't even use parentheses there because it's just one-to-one replacement, replacing every x with an a. All right, so the next one I am going to use parentheses. You'll see that it's important. It won't work if you don't do parentheses. So f of a plus 1 means every time I see an x in the original equation right here, I'm going to replace it with an a plus 1. So I've got negative 2, and for the x, I'm going to write a plus 1. And I have a squared there, and then that's still plus 1. So now, as you can see, I'm going to have to distribute this across a squared binomial. So I'm going to give myself a little more room. Negative 2, first I'm going to leave that out and go ahead and square the binomial. So I get a squared plus 2a plus 1 plus 1. Okay, and then I'm going to distribute the negative 2. So I get negative 2a squared. Plus, the next one is a minus, actually. So that's going to be minus 4a, and then negative 2 times 1 is minus 2, and then there's a plus 1. So I have to rewrite this because I have to combine these two right here. So I get negative 2a squared minus 4a minus 1. So I have one more thing to evaluate, and that is f of 1/2, which means I need to put a 1/2 in every time I see an x. So I get -2 times 1/2 instead of x. And that is squared plus 1. All right, so I have -2. 1/2 squared is 1/4. Square the top, square the bottom, and you get 1/4 plus 1. So I'm running out of room here, so I'm going to go to the right. -2 times 1/4 is -1/2 plus 1, and that is going to equal 1/2. So it's basically 1 minus 1/2. So 1/2 is the final answer there. So before you answer this next check it out, which I'm going to scroll down to now, you might want to go ahead and try some of these odds and look at the answers in the back of the book. So that is your choice. You can pause first. But here is the check it out. So I'm going to pause the video and let you try these. Write the answers to A, B, and C in the Edpuzzle. Here are the answers to the 3. Notice that I've put the number that you're replacing the variable with in red. So just be careful with your work and double check everything before you move on. Here's a few more examples using g of x. Not much is different, but I did want to talk about 25 and 26 and maybe one of the others. So 25 and 26, both of these, there is no x. So the answer to all 3 is just going to be what's given. So for, say, 26, g of x is square root of 5. So there's no place to put -x, there's no place to put 2x, there's no place to put a plus h. So the answer to all 3 questions is still going to be square root of 5. So it's a little tricky, but the point is to understand that you're replacing a variable and there is no variable. All right, so I was going to pick one more to do, and then I'll let you, I would really highly recommend trying a couple of these before you move on. But I am going to do 28. All right, so 28, g of x, and I might not do all 3 of them, but I just want to give you an example, is -1/2 x plus 1. Okay, so we've got g of -x is what they want us to do, g of -x. So everywhere there's an x, I'm going to put in a -x. So I've got -1/2 times, here I'm going to put -x, and I put the rest of it, I just left it blank, and then I'm going to go in and fill in what's in the parentheses there, -x. So then you just want to work this out. You get -1/2 times -x is going to give me 1/2 x, and -1/2 times 1 is -1/2. So that's the final answer on that. For the same one, g of 2x is going to be -1/2 times, I'm going to leave parentheses there, and I'm going to fill it in with 2x. So 2x goes right in there. So now I'm going to distribute the 1/2 across everything. -1/2 times 2x is going to give me -x. -1/2 times 1 is going to give me -1/2. And then the last one is a plus h. So I'm going to do that over here. G of a plus h. And I'm going to just rewrite this and replace the x with a plus h. So -1/2. And I'm putting everything in, and I'm just leaving a blank for where I'm going to put the a plus h. So don't forget, this all comes as a package deal right here. Okay, it's in parentheses. You have to put it all in there together. So then I get -1/2 a minus 1/2 h, and then it's going to be -1/2 again, just like it has been each time. Minus 1/2. So you're distributing the negative 1/2 across the whole thing. Okay, so that is how you do those. And like I said, I really recommend you stop the video here and try at least a couple of these problems in the odds. Okay, next we're going to talk about piecewise defined functions, and you can find these in the book on page 139. And I recommend looking at that if you don't understand any of this. So absolute value is a piecewise function. And what it means is that functions, they're defined using different expressions depending on the different conditions. And a condition, this right here, is a condition. So you're saying if x is greater or equal to 0, then f of x is x. If x is less than 0, then f of x is negative x. So that was the definition of absolute value. If you're graphing on Desmos, I'm going to show you an example of that. You use this syntax right here. Condition, which means what's happening with the values. So if the values are greater than a certain number or less than a certain number, you put that first, then you put a colon, and then you put what the value would be, and then comma, the next condition, and you have to use the curly brackets at the end of either side. Okay, so we're going to try one of these. All right, so evaluate f of -2, f of 0, and f of 1 for each function if possible. So, f of -2 we're going to start with. And these are a little bit different because you have to think, well, what is -2? -2 falls somewhere in these three conditions. -2 is either less than 0, between 0 and 1, or greater than 1. Well, -2 is less than 0. So in that case, we're looking at this condition right here. So we've got f of x equals 0 if x is less than 0. So that means f of -2 is 0. Okay? So I'm going to erase part of my scribbles here and we can move on. So the next one is f of 1. Okay, so f of 1 is not less than 0. It's not greater than or equal to 0 or less than 1. It is greater than or equal to 1. That's where 1 falls. So that means f of 1 is 4. Okay, so again, I'll erase that and we can move on. The next one, I missed 0. F of 0. So those are the three different parts of this question. F of 0 is going to be the middle one. So if it's greater than or equal to 0 and less than 1, then it's equal to 2. Okay, and I wanted to show you the graph on Desmos. So this is kind of interesting. As you can see, there's no x value in any of these right here. That means they're all going to be horizontal lines. So this is y equals 0. Remember that y equals f of x. Okay, y equals f of x. Very important to remember. So, and this one is y equals 4. And this one is y equals 2. Those are all horizontal lines. So this is what this looks like. The orange lines here. And you can see over here on the left that this is how you set up when x is less than 0, then y equals 0. If f of x is between, or if x is between 0 and 1, including 0, then the value is 2, and so on. And so you end up with 3 horizontal lines that end at a certain point. Okay. So I'm going to go on to the next problem. All right, so in this case, we're looking for the same three values. So we've got f of 2, and we've got f of 0, and we've got f of 1 that we're looking for. That was the original question for each of these. All right, so f of 2, our conditions are right here. So we want to look where 2 would fall. Well, 2 falls in the second one, this one right here. 2 is greater than or equal to 1. So that means f of 2 is negative x plus 4. Okay, so that means we're going to choose this one, but then we still have to plug 2 in. So we get negative, and if there's an x, I'm going to put a 2, and then I'm going to add 4. So I get negative 2 plus 4, which is just 2. And I realized that I actually needed to do f of negative 2. So we're going to do that one last, and I'll just continue on with these. Okay, so the next one is f of 0. F of 0 is going to be the top choice. 0 is less than or equal to x is less than 1. So, and if you don't understand that, stop the video and think about it for just a second. But that means we're going to plug into the square root of x, which is going to be the square root of 0, because we just put 0 in for x, which is just 0. All right, the next one is f of 1. 1 falls in the first one, so that's square root of x. We just find nope. This is really, these are hard to think about and talk about at the same exact time. So I just realized that f of 1 actually falls in the first one, or the second one, this one here. Wish these videos were easier to back up and re-speak, but they're not. So it's the second one right here. So x is greater than or equal to 1. So f of 1 falls into that condition. So we get negative x plus 4. So f of 1 is negative, and we're just going to put the 1 in there. And I did that because I wanted you to think about the negative and how it would impact it, but you don't have to do the parentheses when it's that simple. So negative 1 plus 4 equals 3. Okay, the other one I wanted to make sure to do was f of negative 2. So I'm going to erase this line that I did because we have to decide which condition this falls into. F of negative 2. So we've got from 0 to 1, and we've got greater than 1. So there's no choice for anything less than 0. So that means what we're going to write as our answer for negative 2 is undefined. And this is kind of where this term comes from. This is our definition of the function right here. And negative 2 is not defined. There's no definition for it, so it's undefined. Okay, the next thing I'd like to talk about is domain and range, and first I need to define what those are. So domain of a function is the set of all input values. So generally that's x, or the x-axis. Okay, regardless of what variable they use, it's the x-axis. So it's got to produce a real number. And so then the definition of range of a function is a set of all output values which correspond to at least one element of the domain. So basically the range is what we get. It's the the y-axis. It's the values that we get after we put x in. So it's the output values. All right, so we want to look at some examples here. Find the domain of each of the following, and we need to write them in interval notation. So what you're looking for, is there anything that limits what we can put in or get out of the equation? So on number 56, well, first that we want to think about the things that can limit. There are two things that limit right offhand. There's other things, but at this point, there are two things that limit our domain. One is square roots, because we can't take the square root of a negative. And the other is the denominator. Okay, so what do you think about the denominator? What's limiting there? Well, it can't equal 0. And this, it can't be negative or less than 0. Okay, so one can't be 0, the other one can't be less than 0. All right, so let's move on to this one. This one does not have a square root, and it doesn't have a denominator. And any number that you put into this equation is going to just give us a real number. So there's no limits to this one. And so what we're going to say for this is that it's all real numbers. Another way you may see this is the set of all real numbers with a double R like that. That's how they do a set of all real numbers. And in interval notation, we say from negative infinity to positive infinity. Okay, so that's it for that one. Number 60 is h of t equals 3 over 1 minus t. So here we do have a denominator, and this is going to be limited by what can go into the denominator. In other words, we know that we can't divide by 0. So this whole denominator cannot equal 0. Okay, so that's how I'm going to set it up. I'm going to say 1 minus t cannot equal 0. So that means if we subtract 1 from both sides, or you might just see it there, but anyway, if we subtract 1 from both sides, negative t cannot equal negative 1, which means t cannot equal 1. Okay, so that means that it's going to be all real numbers except for 1. All real numbers except for 1. So the way we say that is, and remember to always go, I saw some problems with this on the quiz. We start on the left, and left is negative infinity, and it goes up to 1. It does not include 1, so we put a curved bracket, and we union that with starting at 1 but not including 1. This is the only way to use the interval notation and leave one single number out. Okay, so we union it, and this union is basically saying that it's everything from the left to the right except for what's in between, and the only thing in between is 1. So that's how we do interval notation, to show one number is not included. All right, the next one is just a tiny bit more complicated because we have a square. So once again, x squared minus 9 cannot equal 0. I'll give myself a little more space here. So we're going to set x squared minus 9 not equal 0. So some people use equal 0 and then just try to remember that that's not going to work, but I just like to say it cannot equal 0 and just leave it like that through the problem. So I'm going to add 9 to both sides and I get x squared cannot equal 9. Again, I'm going to take the square root of both sides and I'm going to say x cannot equal plus or minus 3. Either one that I put in is going to be squared and they're both going to equal 9. So you got to make sure and say both of them. All right, so this is an easy way to say it. Now you've really got to think through how to write the interval notation. I'm going to write a quick line so that we can think about this. So we've got negative 3, we've got positive 3, and the whole thing is included. So I'm going to do it in a different color here. The whole thing is included except for 3 and negative 3. Okay, so everything between them, everything above, and everything below. So how do we put that in interval notation? So we're going to say, well, it starts at negative infinity. So start on the left end down here, and that's negative infinity. And it goes up to negative 3, but it does not include negative 3. So I've got to end the bracket there. That's going to be union with, well, it starts at negative 3, but it doesn't include negative 3. And it goes up to positive 3, but doesn't include positive 3, and stops there. And then it's union with positive 3 up to positive infinity. That's how you use interval notation to show all of that. Okay, so this is the last example that I have for you, and so there's a couple things you really have to think about here. You've got a denominator and you have a square root in the denominator. So we are going to work on what has to not be happening here. So we know that 8 minus x has to be positive. So it's got to be greater than or equal to 0. But also the denominator can't be 0, so it can't be equal to. So that's not a possibility. So basically we just are going to say 8 minus x has got to be greater than 0. That's our only choice. So I'm going to subtract x from both sides, and I get negative x is greater than negative 8. I'm going to divide both sides by negative 1. And when I do that, I'm going to switch the sign, so x is less than 8. So this is only going to work if x is less than 8. So I had a lot of people having problems with these kind of problems on the quiz. Please make sure you check some numbers. X has got to be less than 8. It can't be greater than 8. So put a number greater than 8 in here. Put 10 in. Well, you get 8 minus 10, and you get a negative number, so it's not going to work. Put 8 in. You get 8 minus 8, which is square root of 0. That's not going to work. So that's a great way to test it. Test something less than 8 and see if it works. Put 0 in. That's easy. 8 minus 0 is 8. Square root of 8. That's fine. Okay, so that is the last example that I have. So lastly, what I'd like you to do is try these 4 different problems and write your answers in interval notation. So you're just going to put A, B, C, and D and put the answer in the Edpuzzle. Good luck. Let me know if you have any questions in class. Okay, here's your answers. I'll talk about them real quick. A, there's nothing limiting t squared, so it's going to be all real numbers from negative infinity to positive infinity. On B, you cannot have, it won't be a real number if it's anything less than 0, so I set it greater than or equal to 0. It's got to be greater than or equal to, so I set x minus 4 greater than or equal to 0. And I ended up with from 4, including 4, to infinity. And if you think about it, 4, if you just plug 4 in to this equation right here, you're going to get 0, and you can take the square root of 0. So just think those through a little bit once you've written them down. On C, 2x plus 1 can't equal 0, so this whole denominator here cannot equal 0. So you set 2x plus 1 not equal to 0. So you end up with x not equal to negative 1/2, and you write the interval notation like this. So everything except for negative 1/2 is written like that. The last one is similar to the one that I did last. T minus 4 can't be 0, and it can't be less than 0, so it can only be greater than 0. So I set it t minus 4 greater than 0. I started to write greater than or equal to, but it can't be equal to, so I crossed that out. And so t must be greater than 4. And again, check that. Check 5 or 10 or something simple, and check something less than 4 and see what happens. So you're going to find that the interval notation then is from 4 to infinity, not including either one of those things. Okay, that's it. Good luck with this section on the homework. And actually, this is for class next time, so you don't have homework on it yet. So come with questions. Come to class with questions, please. Thanks.